Hello everyone, welcome to Physiology. Today I am going to explain electromagnetic radiation from electrotherapy basic physics. This is a very vast topic, so I'll be covering this topic in 2 to 3 videos. So any physics part, if we know why are we learning this and how are we utilizing this part, physics part in our physiotherapy, it will be very easy to understand the physics part. So now coming to my topic, electromagnetic radiation is used in physiotherapy modalities such as UVR, that is ultraviolet rays, infrared rays, IRR, laser. So these kind of radiation therapies will need electromagnetic radiation. So if we know why are we using, it will be very easy for us to learn about the physics part. So coming to the topic, EMR. What is EMR? EMR is a form of energy, that is the electromagnetic radiation is a form of energy that travels in the form of waves through the oscillating electrical and magnetic field. There will be electrical field as well as a magnetic field. The waves travel. So here what we have said is electromagnetic radiation, how are they produced? So normally electron, if it is not disturbed, it will be in its ground state. So electron will be in ground state. If you give some energy, the energy might be in any form, might be in electricity, or might be in the heat form, okay, or it might be in the light form also. So if you give any electricity or any energy to the electron which is in the ground state, that is in the free state, in the normal state, it will be getting excited and it will be moving to the excited state, that is the higher energy level. From the lower energy level it moves to the higher energy level by absorbing the energy. So after absorbing, it can't stay over there because the energy that it has taken is not sufficient enough to stay in the higher energy level. So what will it do? It again comes to the ground state or the lower energy level by giving out the absorbed energy, whatever energy it has absorbed, no, so it will be giving out in the form of a photon. So that is, this photon is nothing but light. In the form of light it gives off the energy. That is only called as electromagnetic radiation. So once again I'll be explaining you with the brief this thing. So electromagnetic radiation is produced by the movement of the electrons within the atom. So the electrons will be moving within the atom. So this is an atom, the electrons moving within the atom. So electrons move out to the higher energy electron shell. So electrons move out to the higher energy electron shell, that is to the excited state. I have written ES. ES stands for excited state. So when the electrons return to the normal level, the absorbed energy is released as a pulse of electromagnetic energy, that is photon. I've said, so they go to the higher energy level, but they can't stay at the higher energy level, so they have to come to their ground state or the original position or the lower energy level. So while coming down, it really whatever energy it is absorbed, it will be giving off. So it will be giving off in the form of a pulse of electromagnetic energy. Electromagnetic energy is nothing but a photon. And next is type of EM waves produced depends on what type of EM waves. There are a vast spectrum for the electromagnetic waves depending on the waves wavelength and frequency. We will be dividing it into many types. So in the next video I'll be telling you about those things. So type of the EM produced, electromagnetic wave produced, depends upon which electron shell involved in the electron. When certain elements are heated, if you heat this element or if you heat this atom, it will be going to the electron will be going to the excited state. So which shell it has involved? Now here I have given you SPD, it has moved to the D shell. So D shell is having more energy. If it goes to the P shell, it will be having somewhat less energy. So type of the energy absorbed and how much energy it has absorbed. So according to that and which electron shell is involved. So based on that, the spectrum will be changing. Next example. So here I have given you an example, that yellow for sodium, that is sodium. It's an example for tungsten, which we use in the 0 volts bulb we tell it as. So which will be producing a lot of heat when it is switched on. So yellow for sodium. So what is it actually is? So in our bulb we'll be filling it with a gas. The tungsten will be there. The tungsten is nothing but the filament. In the bulb you will be having some gases. So tungsten illustrates the phenomena well. So that is the electromagnetic radiations phenomena is more well good seen in the tungsten. So when it is first heated, the IR, that is the first heated, the infrared electromagnetic waves are produced. So IR is one type of electromagnetic waves are emitted, and it is felt as heat. So always remember, IR, infrared rays, produce heat. As more energy is added, so first you switch the bulb on, so it will take some energy and it will produce the heat. Again you give energy, or more and more energy is been added upon. The energy jumps between the electron shells becomes bigger. So now first it was in the S shell, it was in the S shell, you gave some energy and it moved to the P shell. Again you added on, keep on adding the energy, it will again move to the D shell. Again if you keep, it will move to the F shell. So eventually reach the visible spectrum. It's again one more spectrum in the electromagnetic radiation, so that the metal glows red and then white as temperature increases. So in the next video I'll be giving you a brief about the detailed description about the electromagnetic spectrum also, and also laws governing the electromagnetic radiation. Thank you.